Hello and welcome. It is said that if you divide by 0, then the world will end. Well, we're here today to destroy the world. Now, you can't divide by 0 in a field, so we're going to need a different kind of algebraic structure, and that's going to be the wheel. A wheel is an algebraic structure consisting of any set or collection of objects, an additive identity, a multiplicative identity, two binary operators to go along with those, and a unary operator, which I'll call slash. And as long as all of this satisfies certain axioms, then it's a wheel. And today we're going to be focusing on a particular wheel where we take the real numbers and add two new elements, which I'll call infinity and omnity. And someone called this Omnity, and I thought that was a good name for it, and I'll explain why later. Before we define the wheel of real numbers, we're going to go through all of the axioms for any wheel at all, including the wheel of real numbers. So first thing is we have that addition is associative, commutative, and 0 is the additive identity. So this is really nice because it means when you write an expression involving just pure addition, you don't have to worry about parentheses, you don't have to worry about what order the symbols are in, the terms are in, right? You can just kind of write it. And of course 0, just like in the field, is our wonderful additive identity. And very nicely, multiplication is going to be exactly the same, except now we have 1 as our multiplicative identity. Let's talk about our operators real quick. So addition is a binary operator because it takes two inputs and gives us an output. Now slash is a unary operator, meaning it takes just one input and gives us an output. In other words, slash of 5 equals the output, which in this case, for the wheel of reals, would be 0.2. So the way you can kind of think about it is slash 5 is division by 5 in a sense. If I took, say, 3 multiplied by slash 5, that would be the exact same thing as just taking 3 and dividing by 5, which would give me 0.6. Just to kind of give you some intuition for this slash. We have some axioms for our slash operator. So slash x equals x. For example, if I divide by 5, I get 0.2. And then if I divide by 0.2, I get back to 5. So two slashes cancel each other out. It's called an involution. It's quite nice. We also have that slash distributes over multiplication. So dividing by x times y is the same as dividing by x and then dividing by y, in essence. 0 times 0 equals 0. Any complaints? This axiom is really interesting. X plus 0 over 0 equals 0 over 0. Red Beanie Maths described 0 over 0 as the black hole number because it just sucks anything into itself. And this, the way you want to think about this is that this is 0 times slash 0. But we can also think of it as just a singular number, which is going to be referred to in this video as omnity. Next, we have our distribution axiom. So xz plus yz, I can just factor out the z, like so. And this would always hold true in a field, but for the wheel, in order to make things work the way we want them to work, we have to also add what's called a zero term, in this case, 0 times z. So the way I like to think about this is that under ordinary circumstances, this will be good enough. But for extreme situations or situations that just kind of go, you know, a little bit to weird math land, like for example, z equals infinity, this 0 term is going to save us to kind of make everything make sense in the end. We have x plus yz times /y, which I'm just going to think of as dividing by y. So x divided by y is x divided by y. Yz divided by y, the y's are going to cancel to just give us z. And then we have this 0 term with y. Now, if that seems kind of weird over here, just think about it as this is ordinarily true. Well, we want everything to appear the same number of times on both sides. So x appears once on this side, x appears once on this side. Z appears once on this side, C appears once on this side, /y appears once on this side, /y appears once on this side, y appears once on this side, and y appears once on this side because we forced it to by adding this 0 times y term, right? Without that, we have an imbalance, and we fix the imbalance by adding that 0 term. We're gonna make good use of this axiom, and I really like this axiom. Let me explain why. So here I have x times z gives us x times z. That makes sense, right? And then I have this 0y in here, and we're just gonna kick the 0y to the outside. It's in the parentheses, but we're just gonna kick it out and just say, go be free. And that's how this axiom works. Very mathematical explanation, but it's true. We have the exact same thing going on when we have slash of x plus 0y. Well, slash of x just gives us slash x, and then the 0y we say, go be free. Just leave the parentheses and come on out over here. Those are all of the axioms for a wheel. And now we're going to turn our attention to the wheel of real numbers. So what does slash send 0 to? That's going to be the infinity element. So that's just going to be defined as /0. And 0 times /0, that's going to be the Omnity element. We want addition and multiplication between ordinary real numbers to work in exactly the same way that they work in the field of real numbers. So 5 times 2 is still 10, 17 plus 4 is still 21. But we do need to extend addition and multiplication to be able to handle the new elements, infinity and omnity. Now, omnity is going to be handled by the axioms, but we really do need to explain how infinity works. Infinity plus a real number is just going to be defined to be infinity. Well, that's pretty nice. Infinity times a real number is just going to be defined to be infinity, as long as the real number isn't 0, because infinity times 0 is going to be something else. And we also have to define what slash does, and slash of a real number is just going to be the multiplicative inverse of that real number, so long, of course, as it's not 0. So for example, slash of 10 is just going to be 0.1. Slash of 0.1 is just going to be 10. We can also define subtraction and division in the intuitive way. X minus y is just x plus -1 times y. X divided by y is just x times /y, which we can write like this as well. This is how I like to picture the wheel. So this here is the real number line. So I take the real number line and I sort of bend it up into a circle, and then there's a little gap at the top, and I fill that gap with infinity. Now, I could have called this element anything that I wanted to call it, but I call it infinity because it's cool. Anytime you can name something infinity because it sort of kind of seems like an infinity, well, you should, because it's awesome. And it sort of serves as like the biggest element in some sense. Now, in this direction, we have all of the negative real numbers, and in this direction, we have all of the positive real numbers. In this infinity, it's not positive infinity. It's not negative infinity. It's just infinity. It's unsigned infinity. Now over here we have Omnity, and it's not even on the wheel. It's just sort of like out here in nowhere land. And the way I like to think about Omnity is it's sort of like the entire wheel itself. It could be anything on the wheel. It's sort of like an electron cloud or something, like spread across the whole wheel. Now we are going to use the axioms to find the values of these things. Omnity times x, slash of omnity, infinity plus infinity, infinity minus infinity, infinity times infinity, infinity times 0. And by the time we're done with all of these, we're basically going to know everything about how arithmetic works in our wheel. Anything else you can think of is just going to be follow immediately from one of these, essentially. Infinity plus infinity equals, by definition, slash 0 plus slash 0. And we could write that as 1 times slash 0 plus 1 times slash 0 because 1 is a multiplicative identity. Now what we're going to do is we're going to factor out the slash 0. So we're going to have 1 plus 1 in the parentheses, and then the slash 0 that we factored out. However, we are going to need the 0 term, because remember this axiom, when we factor out the z, we need the 0 times z. Well, we factored out the slash 0, so now we need the 0 times slash 0. But omnity plus anything, it's the black hole number, right? So here, we're just going to get omnity. So infinity plus infinity is omnity. Infinity minus infinity is going to work out the exact same way, except instead of getting a 1 plus 1 in the parentheses, we're going to get a 1 minus 1 in the parentheses. But it doesn't matter what's in the parentheses because the omnity shows up here, so we're going to get infinity minus infinity equals omnity as well. Infinity times infinity is equal to slash 0 times slash 0. Now remember that slash distributes over multiplication like this. So let me show you what I'm thinking here. Let's just think backwards for a moment, okay? So I start with this, and then the slash distributes over the multiplication. So I get slash 0 times slash 0. See? From this axiom. Except I'm just going backwards. So here I have this, and then I go to here, which is this. And 0 times 0, well, that's 0. That was actually an axiom that we had. So this is slash 0. And slash 0 is just infinity. So infinity times infinity is infinity. Infinity times 0 is equal to slash 0 times 0. Do you see what is lurking here? I can just put the 0 on the other side, and I just get 0 over 0. So this is omnity. What is omnity times x? Well, let's first think about 0x plus 0y. This is going to be equal to 0 plus 0x all times y. What is going on here? So it's based on this axiom. You see, this part is like this part, and this part is like this part. So let's think backwards for a moment here. What I'm doing is, see how the 0y here gets kicked to the outside? Well, I'm taking this 0x and kicking it to the outside. That's where this 0x term comes from. And then, once this 0x is kicked to the outside, I just have left 0 times y, which is where this 0y comes from. So I kick the 0x to the outside, that's where the 0x comes from, and then 0 times y, that's where the 0y comes from, all from this axiom. Now, 0 plus 0x is just 0x, because 0 is the additive identity. So this is actually just 0x times y, or 0xy. So I can just combine 0 terms in this way. It's really nice. And then if I have omnity times x, that's just going to be 0 times slash 0 times x, which I could also write as 0 times slash 0 times x. And if you look carefully at this, it's kind of like this. I've got 0, 0, slash 0 is the x, and x is the y. Now, when I have 0xy, I could separate it out into 0x plus y. And here I have 0 with these two inside, and I can separate them out. So 0 times slash 0 is 0 slash 0. 0 times x is 0x. And just like the 0xy becomes 0x plus 0y, this is going to become 0 over 0 plus 0x. And this is going to be our nice black hole number. Just going to suck everything into itself. And so we're going to get omnity. So omnity times anything is omnity. Omnity plus anything is omnity. The only thing that we haven't looked at is what does slash send omnity to. Slash omnity equals slash of 0 over 0. And I can just write this as 0 times slash 0. So I have slash of 0 times slash 0. So I haven't really changed anything here. I'm just putting the multiplication symbol for emphasis. Because remember, slash distributes over multiplication, like in this axiom. So I have slash of 0, and then I have slash of 0, and then between the two I will have the multiplication sign. And slash slash just cancels itself out. So this is going to be slash 0 times 0, which is going to be 0 over 0, which is omnity. So slash of omnity is omnity, which means taken all together, if omnity appears once, everything just gets sucked into it, right? With no question. Let's talk about one last thing here. Infinity plus infinity is omnity. Infinity times infinity is infinity. When I first saw that, I was like, oh, I don't know if I like that. That's weird. And I had to think about it to kind of come up for like an intuitive explanation that made sense of it for me. And I did find one. So infinity plus infinity is kind of like an indeterminate form. Now you might say, what are you talking about? Infinity plus infinity, if it's anything, is infinity. But remember, this is not positive infinity plus positive infinity. This is unsigned infinity plus unsigned infinity. If I look back at the wheel here, I could imagine I have a quantity going to infinity from the positive side, so in the limit it is infinity. And then I have a quantity going to infinity from the negative side, so that in the limit it is infinity. So each one by themselves in the limit goes to infinity. But when I add them together, they're going to cancel each other out, right? Maybe when this one's 10, this one's negative 10. When this one's 100, this one's negative 100. 1000, negative 1000. So that when I add them together, it always cancels out, right? It would be kind of like if t goes to infinity and I take t plus negative t. So t, as t goes to infinity, t goes to infinity. As t goes to infinity, negative t also goes to infinity, just from the negative side. But when I add them together, I get 0, so that as t goes to infinity, the t plus negative t is going to go to 0. So in that case, infinity plus infinity equals 0. But I could change these, so instead of negative t, I could have negative t minus, I don't know, 101 or something. Now I still have the same indeterminate form thing going on, but now instead of equaling 0, it's going to equal negative 101, so that in the limit, I now have an example where infinity plus infinity is negative 101. I could set this up to get infinity plus infinity to be equal to anything that I want it to be equal to. That's what makes it like an indeterminate form, right? But that's not true with infinity times infinity. No matter how I try to come up with it, if I have one quantity that's going to infinity from either side, or maybe even bouncing back and forth or something, and then I have another quantity that's going to infinity, then when I multiply the two together, I'm just going to get a bigger and bigger and bigger thing that's also going to go to infinity. Now, it might flip-flop back and forth between negative large numbers and positive large numbers. Like I might get like a sequence like this or something. But guess what? This sequence is still tending towards the unsigned infinity in the limit. So I can never get something like infinity times infinity equals 100. That's impossible. It has to be infinity. So that's what makes these two so different from each other. That's the end of the video. I hope you found it interesting and enjoyable. If you have any questions, then I can try to answer them. And there also might be a hidden video link in the description or comments with more technical details. If I get around to it, it might be there. Also, I do want to upload some new videos soon that are going to be way more interesting than dividing by 0. One's going to be about how to predict the future. It's super crazy, pure mathematics. And I am trying to be more consistent with uploading. Just have to, try to get better at that. So thank you for watching and take care.